Okay, now we are going to start an extremely important chapter of integration, which is called as multiple submultiple. As the name suggests, it has been derived from multiple submultiple angles formula of trigo. How do I identify this type? The sum is going to be of the order integral of 1 upon a plus b sin x, or it will be of the order 1 upon a plus b cos x, or it will be of the order integral of 1 upon a plus b sin x plus c cos x. If the sum is of this order, if the sum is of this type, that means it has to be of multiple submultiple type. If it is of multiple submultiple type, the easiest way to solve the sum, or the method to solve, first thing that you will have to do to solve the sum is substitute the value of sin x as 2 tan x by 2 upon 1 plus tan square x by 2, and substitute cos x as 1 minus tan square x by 2 upon 1 plus tan square x by 2. Once you've done that, the third thing that you have to do is substitute tan x by 2 as t and differentiate. If you do these three steps, you can easily solve this type. We'll just go through this once again. The multiple submultiple type is going to be of the form 1 upon a plus b sin x with respect to x, or 1 upon a plus b cos x with respect to x, or 1 upon a plus b sin x plus c cos x with respect to x. If once you have identified the multiple submultiple type, the method to solve this is substitute sin x as 2 tan x by 2 upon 1 plus tan square x by 2, cos x as 1 minus tan square x by 2 upon 1 plus tan square x by 2. Once you are through with the substitution, the next thing that you have to do is substitute tan x by 2 as t. Let us try to illustrate this with the help of few sums. Integral of dx upon 5 plus 4 cos x. Guys, this is of the order 1 upon a plus b cos x. Now, I'll say let I integral of dx upon 5 plus 4. Substitute cos x as 1 minus tan square x by 2 upon 1 plus tan square x by 2. Right? This can be written as integral of, take LCM in the denominator. This is going to be 5 plus 5 tan square x by 2 plus 4 minus 4 tan square x by 2 upon 1 plus tan square x by 2 dx. I am taking the common denominator in the numerator. This is going to be integral 1 plus tan square x by 2 is sec square x by 2 upon 5 tan square x by 2 minus 4 tan square x by 2 is tan square x by 2 plus 9 dx. Let tan x by 2 be equal to t. Differentiate with respect to x. d by dx of tan u is sec square u d by dx of u. So that is going to be d by dx of x by 2 is dt by dx. This is nothing but sec square x by 2 into 1 by 2 is dt by dx. This can be written as dx is 2 upon sec square x by 2 dt. Substitute this. If I substitute this, I can say I is integral of sec square x by 2 upon t square plus 9 dx can be written as 2 sec square x by 2 dt. This can be written as 2 common integral of 1 upon t square plus 3 square dt. 2 1 upon x square plus a square, 1 upon a tan inverse of x by a plus c. So the answer is going to be 2 upon 3 tan inverse of t tan x by 2 by 3 plus c. That will be your answer. Let's move on to the next one, guys. Integral of dx upon 4 plus 5 cos x dx. Right? Let's see this. I can say I is integral of dx upon 4 plus 5. Use the multiple submultiple formula. 1 minus tan square x by 2 upon 1 plus tan square x by 2. This can be written as integral of LCM. This can be written as 4 plus 4 tan square x by 2 plus 5 minus 5 tan square x by 2 upon common denominator goes up 1 plus tan square x by 2 dx. This can be written as integral of sec square x by 2 upon 5 plus 4 9 minus tan square x by 2 dx. Let tan x by 2 be equal to t. Differentiate with respect to x. If I differentiate with respect to x, in the last time I showed you that 2 upon sec square x by 2 dt is going to be equal to dx. I'm using d by dx of tan u, which is sec square u du by dx. So I'll get I is integral of sec square x by 2 upon 9 minus t square. Dx is 2 upon sec square x by 2 dt. This is integral of 2 can be brought out. 1 upon 3 square minus t square dt. Guys, let's have a look at this formula. Very interesting formula. Integral of 1 upon a square minus x square with respect to x is 1 upon 2a log mod a minus x upon a plus x plus c. Fine. Should be a plus x upon a minus x plus c. That is the formula. If I use that formula here, 2 as it is, 1 upon 2a log mod 3 plus t upon 3 minus t plus c. So in which case you will get this answer as 1 upon 3 log mod 3 plus tan x by 2 upon 3 minus tan x by 2 plus c. That's the answer. Right? Next, let's see the next one, guys. Integral of dx upon 5 plus 4 sin x. Right? Let's see this. This can be written as excuse me, integral of dx upon 5 plus 4, use the submultiple formula, 2 tan x by 2 upon 1 plus tan square x by 2. Right? This can be written as integral of, take LCM, 5 plus 5 tan square x by 2 plus 8 tan x by 2 upon 1 plus tan square x by 2 dx. This can be written as integral of sec square x by 2 upon 5 tan square x by 2 plus 8 tan x by 2 plus 5 dx. Let tan x by 2 be equal to t. Differentiate with respect to x. So you will get dx is 2 upon sec square x by 2. I explained this to you in the first sum. Dt. So you will get I is integral of sec square x by 2 upon 5t square minus plus 8t plus 5 upon 2 sec square x by 2 dt. Sec square x by 2, sec square x by 2 cancel 2. Now the denominators are quadratic. Two rules of quadratic: the coefficient of square term should be 1. So I am going to take 5 common out in the denominator. So this is going to be dt upon t square plus 8 upon 5t plus 1. I am taking 5 common. Now in order to do this as a perfect square, I need to find out last term. Last term is given by the formula middle term into middle term upon 4 times first term. So this is 8 upon 5t into 8 upon 5t upon 4 times t square. So t square gone, 1s are 2s are, this is 16 upon 25. Add and subtract 16 upon 25. 2 upon 5 dt upon t square plus 8 upon 5t plus 16 upon 25 plus 1 minus 16 upon 25. I am adding 16 upon 25, I am subtracting 16 upon 25. This is 2 upon 5 integral dt. This is a perfect square. How do you find the factor of a perfect square? Square root of the first term, square root of the last term, sine of the middle number. Right? This is 25 minus 16, that is 9 by 25. 9 by 25 can be written as 3 upon 5 the whole square. This is 2 upon 5. This is in the form integral of 1 upon x square plus a square, which is nothing but 1 upon a tan inverse of x by a plus c. 5 and 5 gets cancelled, so this is going to be 2 upon 3 tan inverse, take LCM. So this is going to be 5, substitute the value of t, tan x by 2 plus 4 upon 3, common denominator 5 cancels, plus c. Right? Next, let's move on to the next sum, guys. Integral of dx upon 4 minus 5 sin x. Right? Now, this can be written as I is equal to integral of dx upon 4 minus 5 2 tan, I am using some multiple, 2 tan x by 2 upon 1 plus tan square x by 2. This can be written as integral of LCM in the denominator 4 plus 4 tan square x by 2 minus 10 tan x by 2 upon 1 plus tan square x by 2 dx. This can be written as integral of sec square x by 2 upon 4 tan square x by 2 minus 10 tan x by 2 plus 4 dx. Now let tan x by 2 be equal to t. Differentiate with respect to x. So you will get dx is equal to 2 upon sec square x by 2. I could say I is integral of sec square x by 2 upon 4t square minus 10t plus 4. Dx can be written as 2 upon sec square x by 2 dt. Right? This can be written as sec square x by 2, sec square x by 2 gets cancelled. The denominator is a quadratic. Quadratic means coefficient of the square term should be equal to 1, for which I am going to remove 4 common out in the denominator. So this can be written as dt upon t square minus 10 upon 4, which can be written as 5 upon 2t plus 1. Right? In order to make this as a perfect square, you need to find out the last term. Last term is middle term into middle term upon 4 times first term. So this can be written as minus 5 upon 2t into minus 5 upon 2t upon 4 times t square. This is 25 upon 16. This can be written as 2 upon 4, can be written as 1 upon 2 integral of dt. This is going to be t square minus 5 upon 2t plus 25 upon 16 plus 1 minus 25 upon 16. This is 1 upon 2 integral of dt upon, this is perfect square. How do you find out perfect square? Square root of the first term, square root of the last term, sine of the middle number, right? This is going to be 16 minus 25, that's minus 9, which can be written as minus common 3 upon 4 the whole square, right? Now this is going to be nothing but integral of 1 upon x square minus a square. Let's see this formula, guys. Very similar to the formula we had done a couple of sums ago. Integral of 1 upon x square minus a square with respect to x is 1 upon 2a log mod x minus a upon x plus a plus c. Very similar to the previous formula, right? Do we understand this? Now let's see this. There it is plus in the numerator, here it is minus in the numerator. The signs are reversed, okay? Let's see this. So 1 upon 2 as it is, 1 upon 2a log mod t minus 5 by 4 x minus a upon x plus a plus c. This can be written as 4 and 4 gets cancelled. This is 1 upon 3 log mod LCM. This is going to be 4. Substitute the value of t, tan x by 2 minus 5 minus 3 minus 8 upon, this is 4 tan x by 2 minus 5 plus 3 minus 2 plus c. Now in the numerator and denominator I could take 2 common, in which case I will get the answer as 1 upon 3 log mod 2 tan x by 2 minus 4 upon 2 tan x by 2 minus 1 plus c. I have taken 2 common in the numerator, denominator and cancelled it. Fine. Let's move on to the next one, guys. Integral of dx upon 3 1 minus sin x minus cos x, right? Now here you have sin and cos both, so I can say I is integral of dx upon, open the bracket, 3 minus 3 sin x. Sin x I'm going to substitute as 2 tan x by 2 upon 1 plus tan square x by 2 minus cos x, 1 minus tan square x by 2 upon 1 plus tan square x by 2, right? I'm using the submultiple formula with both the terms. Let's do LCM, people. This is going to be 3 plus 3 tan square x by 2, 3 multiplied by the common denominator, minus 6 tan x by 2 minus 1, minus into minus plus tan square x by 2. Common denominator goes up, 1 plus tan square x by 2 dx, right? This can be written as integral of sec square x by 2, 3 tan square x by 2 plus tan square x by 2, 4 tan square x by 2 minus 6 tan x by 2 plus 3 minus 1, that's plus 2 dx. Let tan x by 2 equal to t. Differentiate with respect to x. So you will get sec square you will get dx is 2 upon sec square x by 2 dt. I could say I is integral of sec square x by 2 upon 4t square minus 6t plus 2. Dx can be written as 2 upon sec square x by 2 dt. This can be written as 2. Quadratic in the denominator. Coefficient of square term should be 1. So I'm going to take 4 common out in the denominator. Integral of dt upon 4 is out, t square. 6 upon 4, 3 upon 2, t plus 1 upon 2. Right? Quadratic, perfect square. In order to make perfect square, I need to find out last term. Middle term into middle term upon 4 times first term. Minus 3 upon 2t into minus 3 upon 2t upon 4 times t square. That's 9 upon 16. Add and subtract 9 upon 16. 2 upon 4 will give you 1 upon 2. Integral of dt upon t square minus 3 upon 2t plus 9 upon 16 plus 1 upon 2 minus 9 upon 16. I'm adding and subtracting the same term. 1 upon 2 integral of dt upon perfect square. How do you find out? Square root of the first term, square root of the last term, sine of the middle number. 16, that means 8. 8 minus 9 is minus 1. So this can be written as minus 1 upon 4 the whole square. Same formula that we used in the last sum. Integral of 1 upon x square minus a square, which is nothing but 1 upon 2a log mod x minus a upon x plus a plus c. Right? This is going to be 4 and 4 gets cancelled. So this is log mod LCM 4. Substitute the value of t, tan x by 2. Minus 3 minus 1 minus 4 upon 4 tan x by 2 minus 3 plus 1 minus 2 plus c. Again I can take common. I'm going to complete this sum here. This can be written as log mod. I'll take 2 common in the numerator, so you will get 2 tan x by 2 minus 2 upon 2 tan x by 2 minus 1 plus c. That will be your answer. Let's move on to the next one, guys. Integral of dx upon 2 minus 3 sine 2x. Here instead of sum multiple, you will have to use multiple angles. So I can say I is integral of dx upon 2 minus 3 sine 2 theta. Sine 2x is 2 tan x upon 1 plus tan square x. This can be written as integral of dx upon 2 plus 2 tan square x minus 6 tan x. Common denominator goes up. 1 plus tan square x dx. Identities. 1 plus tan square x is sec square x. This is 2 tan square x minus 6 tan x plus 2 dx. Let tan x equal to t differentiate with respect to x. D by dx of tan x is nothing but sec square x. So I'll get sec square x is dt by dx. Therefore you will get dx is dt upon sec square x. I can say I is integral of sec square x upon 2t square minus 6t plus 2, dx can be written as dt upon sec square x. Sec square x gets cancelled. Quadratic coefficient of square term should be equal to 1. So in order to make the coefficient of square term 1, I'm going to take 1 upon 2 common. So this is going to be dt upon t square minus 2. So 3t plus 1. Okay. Now perfect square. In order to make this as a perfect square, you need to find out last term. Last term is middle term into middle term upon 4 times first term. That is minus 3t into minus 3t upon 4 times t square. That's 9 upon 4. This can be written as 1 upon 2 integral of dt upon t square minus 3t plus 9 upon 4 plus 1 minus 9 upon 4. This is 1 upon 2 integral of dt. Now, this can be written as perfect square. How do you make perfect square? Square root of the first term, square root of the last term, sine of the middle number. This is 4 minus 9, that is minus 5, which can be written as minus root 5 upon 2 the whole square. Same formula that we've been using in the past two sums. Integral of 1 upon x square minus a square is 1 upon 2a 1 upon 2a log mod x minus a upon x plus a plus c. This can be written as 1 upon 2 root 5 log LCM 2, substitute tan x by, no, tan x. Here it is tan x. 2 tan x minus 3 minus root 5 upon 2 tan x minus 3 plus root 5 plus c. That would be your answer. Let's see the next one, guys. Last sum to finish this chapter. Integral of dx upon 2 minus 3 cos square x. Right? Now let's see this. I can write I is integral of dx upon 2 minus 3. Use multiple submultiple. Cos square theta is nothing but 1 plus cos 2 theta upon 2. Guys, I'll just explain it to you how we get this. We know that cos 2 theta is nothing but 2 cos square theta minus 1. So 1 plus cos 2 theta upon 2 is cos square theta. That's how I've used this formula. I brought the 1 on the other side, I brought 2 in the denominator, and that's how I got this. Okay. Now, let's see how we can solve this. This is going to be, let's see this, dx upon LCM. dx I won't need. Let's see the LCM. This is going to be 4 minus 3 cos 2x upon 2 dx, common denominator. I brought it in the numerator. Now, this is going to be 2 comes out. Integral of dx upon 4 minus 3 is 1 minus 3 cos 2 theta can be written as 1 minus tan square theta upon 1 plus tan square theta. Multiple angles. Again take LCM. 2 integral of 1 plus tan square x minus 3 minus into minus plus 3 tan square x and upon 1 plus tan square x, common denominator goes up, dx. This can be written as 2. 1 plus tan square x is nothing but sec square x. 3 tan square x plus tan square x is 4 tan square x minus 3 plus 1 minus 2 dx. Let tan x equal to t. Differentiate with respect to x. dy dx of tan x is sec square x is dt by dx. So in which case we can say that dx is dt upon sec square x. I is twice integral of sec square x 4t square minus 2 dt upon sec square x. 2, take 4 common, quadratic, therefore I have to make sure that the coefficient of square term is 1. dt upon this is t square minus 2 upon 4, that is 1 upon 2, which can be written as 1 upon root 2 the whole square, right? Same formula, this is 2 upon 4 is 1 upon 2, same formula that we've been using in the last couple of sums. 1 upon x square minus a square, 1 upon 2a log mod x minus a upon x plus a plus c. So 1 upon 2a log mod x minus a upon x plus a plus c. So this is going to be 1 upon 2 root 2 log root 2 tan x minus 1 upon root 2 tan x plus 1 plus c. Right? I have substituted the value of tan x also. Right? This finishes this chapter. We'll stop here for the day. Thank you very much.